Welcome to this explainer. Today, we're diving into something honestly pretty incredible. We are cutting right through the hype to examine the rigorous, hard scientific data behind turning organic waste, which most of us just see as a massive liability, into a highly lucrative stranded energy asset right in the Indian state of Odisha. Based on the extensively verified research of Professor Kapileswar Mishra, this is a fascinating look at how raw biochemistry meets macroeconomic policy. Let's walk through exactly how this transformation works. Okay, let's dive into this structured journey, taking us from microscopic molecules all the way to legally robust macroeconomic policy. We'll start with the stranded energy asset, look at the science of transformation, measure the economic impact, check out the realities of biogas policy, look at how we overcome barriers, and finally, the biogas renaissance.
Section 1. The stranded energy asset, turning liability into power.
So it is really time we completely reframe how we look at mismanaged waste in agrarian regions. Things like field-burnt crop residue and uncaptured livestock methane, they aren't just garbage. They are a massive uncaptured energy reserve. To wrap your head around the scale, just look at this number, 500 million. That is India's verifiable national crop residue base, 500 million tons per year. You pair that kind of volume with Odisha's incredibly reliable bovine dung supply and growing urban waste streams, and you've got this staggering, consistent supply of raw material just waiting to be tapped. And this brilliantly illustrates exactly why we simply can't ignore this waste. Uncaptured methane, naturally emitted by decomposing organic matter, it has a global warming potential 84 times that of carbon dioxide over a 20-year horizon. Literally 84 times. Leaving it to rot or burn is an environmental disaster, but capturing it, that makes it an absolute climate necessity. Moving to Section 2, the science of transformation, the biochemistry of biogas. All right, so how do we actually harness this stuff? I promise you it's not magic, it's highly predictable biochemistry, governed by stoichiometric predictions like the Buswell-Mueller formula. Basically, the whole oxygen-free anaerobic digestion process happens in 4 sequential stages. First, hydrolysis breaks down the complex matter. Then, acidogenosis converts that into volatile fatty acids. Next up is acetogenesis, which turns those into acetic acid, hydrogen, and CO2. And finally, methanogenesis steps in to actually produce the methane. Get the conditions right, and this precise microbial chain reaction yields an impressive 28 to 40 liters of biogas for every single kilogram of fresh cattle dung. But wait, raw biogas isn't the final product here. By scrubbing out the carbon dioxide, we're left with compressed biogas, or CBG, that boasts over 90% methane purity. And that hits the strict BIS standard for automotive-grade bio-CNG. When you compress it to about 200 to 250 bar, it becomes functionally interchangeable with standard natural gas. So yes, you can literally fuel your car with purified cow dung. Pretty amazing, right? Section 3. Measuring the economic impact. Verifiable numbers, not hype. Now, what's really interesting about this slide is the focus on radical transparency. We are drawing on the 2030 scenario modeled by the Council on Energy, Environment, and Water. And Professor Mishra's research insists on showing exactly what is a proven fact versus what is a modeled projection. Biogas yields and 90% purity standards, those are verified, established facts. The job numbers and market values, on the other hand, are modeled projections. Knowing the difference between the two is absolutely critical for real-world planning. Let's throw out the first major economic metric, 648 tons per day. That is Odisha's identified compressed biogas capacity pipeline right now. And that's not a guess. It is based strictly on officially issued letters of intent from oil marketing companies. That's the baseline capacity waiting to be fully operationalized. Now, if that 648-ton pipeline is actually fully deployed by 2030, the CEW model projects an employment impact of approximately 21,000 cumulative job years. And we aren't just talking about people working inside the plant. This spans the entire value chain, from the initial facility construction all the way down to the massive logistics networks you need to aggregate and transport the feedstock. Capping off these economic metrics is the ultimate market prize. We are looking at a projected $123 million market opportunity by 2030. To actually unlock that market, models indicate we need a capital investment ranging roughly between $24 and $56 million, depending on things like the feedstock mix and site costs. So the upside? It's completely immense. Which brings us to Section 4, Realities of Biogas Policy. the legal framework. Okay, big market numbers require a really solid foundation. While national and state policy frameworks definitely reduce commercial risk for entrepreneurs, they don't completely eliminate it, which brings up a massive misconception that gets repeated a lot in secondary literature. I want you to really think about this. Is India's flagship SATAT scheme an absolute, guaranteed, risk-free purchase contract? Well, the answer is no. There's a myth out there claiming SAT is a take-or-pay offtake guarantee. But the legal reality is quite different. SAT is actually a market development framework. It takes an undefined market and structures it, giving entrepreneurs a known counterparty and standard contracting pathways. But make no mistake, it is not a foolproof, legally binding guarantee to buy every drop of gas produced, regardless of quality. Section 5, Overcoming Structural Barriers, the real-world challenges. So, the crucial point is, we need to maintain absolute impartiality and realism here, because despite the brilliant science and supportive policy, first-generation entrepreneurs face a true operational gauntlet. There are 4 major structural barriers we have to talk about. First, feedstock seasonality. Rice straw, for instance, is only available for a super short 6 to 8 week window. Second is the severe capital intensity. A standard 300-ton per day plant demands up to 150 to 200 crore rupees up front. Third, you've got multi-layered bureaucratic delays in actually getting promised subsidies dispersed. And finally, strict technical compliance for methane purity. If you dip below that 90% threshold, the oil marketing companies will literally reject your gas, costing you your revenue. And that brings us to Section 6, the Biogas Renaissance Framework, a 5-pillar strategy. To actually solve these exact structural barriers, Professor Mishra proposes an evidence-anchored agenda, the Odisha Biogas Renaissance Framework. It's built on 5 pillars to move this from just potential to a permanent reality. First, a centralized entrepreneurship center. Second, a biogas fellowship to train operators. Third, it utilizes a decentralized hub-and-spoke architecture to manage that tricky seasonal feedstock logistics problem we just talked about. Fourth, it demands a diversified revenue stack, meaning you're selling nutrient-rich digestate as fertilizer and tapping into India's verified carbon credit trading scheme. And fifth, crucially, it features tribal-inclusive design, integrating rural self-help groups under Article 46 of the Constitution to ensure equitable, gender-transformative wealth distribution. I want to leave you with this really powerful thought from Professor Mishra regarding this entire transition framework. He writes, its credibility with policymakers, financiers, and reviewers will depend less on the confidence of its language than on whether every figure in it can survive scrutiny. In a world that is just full of hype, radical transparency is the ultimate tool for progress. Ask yourself, how rigorously verifiable is the data driving the major transitions in your own industry? Thanks for joining me on this explainer. I really hope this deep dive into Odisha's biogas revolution leaves you thinking critically about the true power of verified data.